Hello. So today I want to talk about metabolism. In the last 20 years of my medical practice, I've had many patients attend struggling with their weight and really struggling to understand how their metabolism works. And often the metabolism is blamed rightly in certain circumstances for an inability to maintain a healthy weight. And even though lots of us will feel that our metabolism is to blame, seldom will we actually understand the processes by which our metabolism has been changed. So the fundamentals I want you to know about are our body works in a very tight circuit of feedback mechanisms to maintain something called homeostasis. Homeostasis means that everything is just going along perfectly. It's the backward and forward really between the needs and the gives. And we have this homeostasis through predominantly hormonal feedback mechanisms. So when patients will ask me, is it my hormones? Are my hormones out of whack? Is that why I'm gaining lots of weight? It's true, but it's probably not the hormones that they think are at play. So I want to introduce you to insulin and glucagon. So let's start with insulin because it's more well known. Everyone knows about insulin. It's secreted by the beta cells of the pancreas, and it's secreted in response to high blood sugar. Its main role is to then lower that blood sugar by promoting storage and utilization of glucose as a nutrient. So it increases the glucose uptake into muscles and fat cells. It enhances something called glycogenesis, which is converting glucose into glycogen. It's a good storage component. And that glycogen is stored in the liver and the muscles. It inhibits glycogenolysis, which is the breakdown of glycogen. And it inhibits gluconeogenesis, the production of new glucose from non-carbohydrate sources. It also promotes fat storage by stimulating lipogenesis and inhibiting lipolysis. It will enhance protein synthesis, so the making of protein, and inhibit protein breakdown. A lot of medical and biochemical terms there. But the main thing to know that insulin works by increasing the glucose uptake into muscles and fat cells. Does muscles first, but leftover glucose is stored then in fat cells. Glucagon, on the other hand, is the opposite. So it's more of a catabolic hormone. It's secreted by alpha cells of the pancreas, and its role is to raise blood glucose by mobilizing the stored energy that we have. It stimulates what's called glycogenolysis, breakdown of glycogen into glucose. That happens in the liver. It enhances gluconeogenesis, the production of new glucose from other substrates. And it promotes lipolysis, the breakdown of fat for energy. So glucagon is on our side. It inhibits glycogenesis, so it prevents the storage of glucose as glycogen. So these are our balancing hormones. Insulin acts in the fed state, so when we've eaten, to promote glucose uptake and storage, and glucagon acts in the fasted state, mobilizing energy stores to maintain blood glucose levels. So now I want to just explain the key metabolic pathways, and then we'll get on to how we can work these pathways to our favor. So the key metabolic pathways, number one is gluconeogenesis. So that's where we are creating glucose. So we are making glucose from non-carbohydrate sources. So this often will happen in the liver. And the whole point of it is to maintain blood glucose levels. So during times of fasting or starvation or intense exercise, our body will make glucose from non-carbohydrate sources. And these sources are amino acids from muscle breakdown, don't want that, lactate from a more anaerobic metabolism, and glycerol from fat breakdown. It is stimulated by glucagon and cortisol during times of stress and fasting, and it is inhibited by insulin. Now, glycolysis, this is glucose breakdown. So this is the pathway that breaks glucose down into energy. So this happens within the cells. Now, bear with me through a very short, very scientific process. I want to talk about ATP and the Krebs cycle. Bear with me. So ATP is adenosine triphosphate. It is the primary energy currency of the cell. It is composed of adenine, ribose, which is a sugar, and 3 phosphate groups. You don't even need to remember that. You just need to know it stores and transfers energy within cells. It is their energy currency for cellular metabolism. So energy is released when ATP is converted into ADP plus an inorganic phosphate. So ATP is regenerated through cellular respiration, glycolysis, the Krebs cycle, and something called oxidative phosphorylation. Now, Krebs cycle, it is the central metabolic pathway that generates energy from carbohydrates and fats and protein. So we can get energy from carbohydrates, fats, and proteins. The Krebs cycle is predominantly located within what's called the mitochondrial matrix. It produces ATP for energy, and it releases carbon dioxide as its byproduct. So ATP is the energy currency for cells. The Krebs cycle, you'll hear people talking about in scientific circles, is part of cellular respiration. It generates high energy carriers and a small amount of ATP. There's also something called the electron transport chain within this. And electron transport chain uses these carriers, the high energy carriers from the Krebs cycle, to produce the bulk of ATP. And that is what we are ultimately looking at when we look at our metabolism. Can we give our basic cells energy? And how can we maintain that whilst healthily using the energy that we have readily available to us in the form of glucose in our blood, glycogen in our muscles and liver, and adipose tissue, or triglycerides in our adipose tissue. So let's lean towards using lipolysis, using adipose tissue, through a Mediterranean type diet, through lightly elongated overnight fast. And an important aspect to add to this is if you're trying to lose weight, if you can avoid snacking, because every time you have a snack, if you think of it in terms of especially the readily available high carb, high GI carb processed foods, you're spiking your insulin. And every time you spike your insulin, you're putting down fat. So trying to go periods of time without that ready supply of carbohydrates that will be ultimately deposited as fat as we live in a time of plenty and we are not depleting our glycogen stores. I hope that's been useful. I know it's heavy going, but the bottom line is, in a scientific process, to tap into lipolysis, to tap into fat stores for energy, we need to cut down our highly processed carbohydrates. We need to avoid our snacking, and where possible, elongate that overnight fast a little bit. Thank you. So this is regulated by insulin and glucagon. So it's stimulated by insulin and inhibited by glucagon. So that's glucose breakdown, glycolysis. Ketosis. So ketosis is a metabolic state where the body is using ketone bodies for energy. And this will be due to a low carbohydrate availability. People will be aware of intermittent fasting and carbohydrate low diets such as the keto diet, Atkins. So these diets are factored in and around what's called ketosis. Ketosis actually happens predominantly in the liver, where ketone bodies are produced. And they can be readily used by the brain, heart, and our muscles. So if over a period of fasting or very low carbohydrate diets, the liver will convert fatty acids into ketone bodies. And these fatty acids have come from our adipose tissue. So these ketones replace glucose as our energy source. Now, ketosis is normal. It's a normal adaptation to fasting or starvation or a very low carbohydrate diet. There is also something called diabetic ketoacidosis, and this is very dangerous. Diabetic ketoacidosis is where type 1 diabetics are have no insulin and unable to utilize blood sugar that they have circulating. So because they don't have the insulin, they don't have the ability to break down sugar. So sugar becomes very high in the bloodstream, but there's no mechanism by which to put it into cells or to utilize it. So then the body will create ketones. And this could be very acidic for your body. And diabetic ketoacidosis is exactly that. It's a very acidic and dangerous process for your body to be in. The normal individual would not manage to put themselves into that ketoacidotic state, but ketones can be produced naturally and usefully. Let's talk about lipolysis, fat breakdown. That's where the real interest is for us, isn't it? So the breakdown of stored fat by ways of triglyceride breakdown gives us energy in the form of free fatty acids. So breaking down stored triglycerides, we get glycerol and we get free fatty acid. This occurs in our adipose tissue, in our fat stores, and it will provide energy during fasting or increased energy demand. So triglycerides are transferred into glycerol, which is itself used for gluconeogenesis, and free fatty acids, which are used for energy and ketone production. So this is stimulated by glucagon, adrenaline, and also cortisol. And it tends to be stimulated during periods of stress, exercise, fasting. It is stopped by insulin, and it's stopped by eating carbohydrates. If you eat carbohydrates, you spike your insulin. You spike your insulin, you stop lipolysis. So you stop breaking down fat. Now, it's really, really hard for us to break down fat for energy because we live in a time of plenty. And in that time of plenty, we have carbohydrates at our disposal. Everywhere we go, there are carbohydrates to be had. You can order ice cream to be delivered to your door, pizzas to be delivered to your door. When we go and fill our car up with fuel, we run the gauntlet of sausage rolls and donuts and lollies. If we're drinking things like sugary sodas, it's just supplying carbohydrate the entire time and therefore stopping us from tapping into lipolysis. And really, with the whole metabolism processes that we're learning about, the important ones are our body's ability to tap into glucose for energy, whether that be glucose stored as glycogen, or whether that be as creating other glucose or other energy from substrates, because we don't want to be fasting and tired and without the energy, but we do want to be able to bypass or get through those mechanisms of using up the glucose that we have readily available and get into and tap into the lipolysis, the breaking down of adipose tissue for energy. So how do we do it? Certainly prolonged fasting will, but that's just starvation. And if we do that, we know that our hunger hormones, ghrelin, will go up and stay up for 6 years. So if you starve yourself, if you withhold food, if you restrict your eating significantly, your hunger hormone will peak and stay high for 6 years. If, however, we can acknowledge that there's an element of natural fasting overnight, normally about 10 hours, if we can acknowledge that and think, well, that's as close to depleting my glucose stores as I can get naturally without starvation, without me feeling really hungry. If we can then prolong that period a little bit, even to, between 12 and 16 hours, then we've managed to chip away a bit more at our stored energy before we feel hungry, before we feel restricted. Front-ending our day then with low carbohydrate food to fill us up and give us an option, such as omelets and nuts and whole foods without that processed fast-release sugar that we get from cereals and breads and even things like fruit first thing in the morning, spiking that insulin. So my advice to you in terms of managing your metabolism, don't diet. As soon as you diet, your hunger hormone goes up and stays up for 6 years. Try as hard as you can to remove these highly processed carbohydrates that are in such ready supply, that have our insulin pumping all of the time and has us storing adipose tissue readily. If we can get rid of the processed carbohydrates, the healthy whole foods, the fiber-rich carbohydrates that give us slow release sugar from our gut, these prevent that big spike that we're seeing in insulin. Lean meats, whole foods, dark green leafy veg. This is the cornerstone of us having a metabolism that is controllable. And it also means that we're preventing ourselves from storing more fat, but we're also giving ourselves an opportunity to tap into that fat for energy, which is hard to do, and it comes with time. However, if these diets that we're putting ourselves, the keto diet or calorie restriction, if we're depending on them solely because they're leaving us hungry, then they will work against us by increasing our hunger hormones, but also never really getting to the stage where we are tapping into our fat for energy. I'm just going to touch on very briefly a little bit more about our hunger hormones and our satiety hormones. So let's start with leptin. So leptin is our satiety hormone. It is produced by our fat cells, our adipocytes. It signals to the brain to reduce appetite and increase energy expenditure. It should be a perfectly functioning hormone that keeps our weight and our consumption of food in check. It's released when fat stores are sufficient. So you look at our population now and how the obesity epidemic has been growing and growing. Like, surely this leptin should be kicking in. It should be giving the message back to our hypothalamus, our thermostat, to suppress hunger. And it should be regulating our long-term energy balance and metabolism. However, when this has been explored further, it would appear that our body, when gaining weight and sitting at a higher than normal weight, annoyingly, our body gets resistant to leptin. We have leptin resistance. And we've previously thought that this would be the key to weight loss, and it's been looked at and it's been explored. But in actual fact, it's a bit like insulin insofar as out with its very tightly held normal parameters, when we need it most, our body stops listening to it. So if you have been significantly overweight for a period of time, your leptin is probably high, but you've probably developed resistance. Very frustrating. And again, this is an inbuilt mechanism so that we could develop the ability to store and store and store beyond what was necessary so that we could survive famines and floods and natural disasters. But it's working against us now because we live in a time of plenty. If you've never dieted, your leptin will help you with your hunger. But if you have dieted, if you have gone without, if you've been prolonged fasting or have very low body fat levels, then yes, your leptin will be low and will respond appropriately. But if you've ever been overweight, it will be set high and stay high. Now, what about ghrelin? That's our hunger hormone. It's produced by the stomach, mainly, but also in the small intestines. And it stimulates hunger and initiates our want for food. It is released when the stomach is empty, and again acts on the hypothalamus, that thermostat, to increase appetite. It promotes fat storage and prepares the body for food intake. Unfortunately, our ghrelin goes up with dieting, with weight loss, with fasting, and with sleep deprivation. It comes down, however, it does come down with bariatric surgery. We see that it can come down and lower over time with obesity. However, if you are a yo-yo dieter, your ghrelin will be raised, and as I said, raised for about 6 years, we think. So that is why I advocate for not dieting. If you diet and you restrict, your ghrelin will go up and stay up. If you have been overweight for a period of time, your leptin is up and your body has become resistant to it. So these mechanisms that should keep us in a homeostasis, in our Western world where everything is plenty and fad diets have been the norm, these hormones are very out of whack. And these are the hormones giving you problems. It's interesting that we are using things like GLP-1 medications now, because with the slowing of gastric emptying that happens with GLP-1s, your ghrelin, your hunger hormone, gets a chance to come down because that sense in your stomach of empty isn't around. So it's one of the mechanisms by which medications or GLP-1s are actually working with your hormones to improve your long-term relationship with weight gain, appetite. But again, they are not a fast fix. You would potentially have to be on these medications for years and years to right the wrongs of fad diets and our Western lifestyle. Take that knowledge, apply it. And by that, I mean whole foods, cut down on your snacking, look after your gut, look after your sleep, look after your stress levels. It's about the whole lifestyle medicine movement, isn't it? Not just one thing. Good luck. So the key to getting fat utilization for energy is prolonging our natural overnight fast by a little, front-ending our day with protein-rich whole foods, and avoiding the processed carbohydrates that we have in ready supply, because these are hijacking your metabolism by giving you quick release energy that spikes your insulin and causes you to store fat. Now, that is an incredibly brief and simplistic view of one aspect of metabolism. it is important to remember that your metabolism is driven by more forces than just this small pathway that we've mentioned. Your stress hormones, cortisol, adrenaline, your sex hormones, your liver function, your thyroid function, your gut microbiome, your nervous system, your emotion, all of these play a part in your metabolism too. So getting each part of this right puts you on a better pathway to longevity and wellness, but also to that healthy weight that seems so elusive to many of us.